Now that we've done the 30, 60, 90 triangle, we're going to kind of do the same thing with the 45, 45, 90 triangle. So we have sine of alpha, cosine of alpha. Let me space things out a little better so we have room. And tangent of alpha. And remember, sine of alpha is opposite over hypotenuse. Cosine of alpha is adjacent over hypotenuse. And tangent of alpha is opposite over adjacent. And I'm going to call the lower angle alpha. And we'll talk about that in a second. But the opposite side is A. So quick little key, opposite side is A. The side opposite the hypotenuse, or sorry, the 90-degree angle, which is the hypotenuse, that is going to be root 2 times A. And the adjacent side, the side that's next to, but not the hypotenuse, is the adjacent, which is also A in this case. So sine of alpha opposite is A over hypotenuse, which is root 2 times A. The A's cancel, giving us 1 over root 2. And if we wanted to rationalize this, we multiply the top and bottom by root 2, which gives us root 2 over 2. And cosine adjacent, well, that's A. And the hypotenuse, once again, is root 2 over A. And so the same math would occur that we just did above, and so we'll get root 2 over 2 here. For tangent of alpha, the opposite is A. The adjacent is also A. And so A over A, that's equal to 1. And so the nice thing about this triangle, as opposed to the 30, 60, 90, is it doesn't really matter which side, which angle we chose as alpha, because even if we were to have chosen this angle as alpha, well, its opposite side is also A. And its adjacent side, the side that's next to but not opposite the 90 degree, that's also A. So the adjacent side is also A. And of course, it's the same triangle, so they have the same hypotenuse, but the side opposite the 90 degree, that's also root 2A. So regardless of which angle we chose as alpha in this case, we're going to get the same triangle. Okay? And so, like I said before, this is going to be very handy when we create our unit circle in the next section. But there is one more part of this section that we need to cover, which is using the trigonometric functions to find unknown either angles or sides. And since we don't really work too much with the angles yet, well, we'll just get right into it. So assume we have this triangle. Okay. And we have A here. There's our 90-degree angle. Call this C, 7. And this angle is going to be 30 degrees. And one thing, actually, I want to go back and clarify, because I don't think it was super clear, or at least I didn't make it super clear. I said sine of alpha was equal to root 2 over 2. And I said it didn't matter in either case which one you chose as alpha. But notice alpha is 45 degrees. So what we've essentially done is found that sine of 45 degrees, right, because this is that 45, 45, 90 triangle, sine of 45 degrees is root 2 over 2. Cosine, this is also alpha, same, we chose alpha as the bottom. Not that it matters, but we also figured out that cosine of 45 degrees is also root 2 over 2. And the tangent of 45 degrees is equal to 1. Likewise, what we found here is when we chose sine to be the 60-degree angle. We got root 3 over 2. So what this is telling us is sine of 60 degrees, that's equal to root 3 over 2. So these were all for 60 degrees. Cosine of 60 degrees is equal to 1/2. So that's from this part right here. And then tangent of 60 degrees, that's equal to root 3. And then from the second triangle we did where we made alpha the 30-degree angle, that told us we have sine of alpha is equal to 1/2. But remember, alpha was 30 degrees here. So sine of 30 degrees is equal to 1/2. Cosine of 30 degrees, that's equal to root 3 over 2. And finally, tangent of 30 degrees is equal to root 3 over 3. And like I said, we'll come back to using these in the next section, but this was kind of the reason that we went through the proof of the 30-60-90s and the 45-45-90s and used these proportions to kind of give us a more concrete way of understanding why sine of 30 degrees is 1/2, cosine of 30 degrees is square root 3 over 2, and tangent of 30 degrees is root 3 over 3. I don't expect you to memorize this stuff yet, but at some point we're going to use this so much that it's going to be ingrained in you one way or another. All right, so let's go back down to the triangle that I had created. And so the directions here are to find the unknown sides of the triangle. And so we have A and C that we're looking for. And they've only given us one angle, which is the 30 degree. Now, certainly we can figure out what the missing angle is here, right? Because all triangles add up to 180. So even they don't tell us, we know that this is a 60-degree angle, but let's just assume we don't know what it is because it doesn't really matter. What we want to do is use the trig functions we have, the sine of alpha, cosine of alpha, tangent of alpha, and their proportional representations, which was opposite over hypotenuse, adjacent over hypotenuse, and tangent, which was opposite over adjacent, and use these to try to come up with an algebraic equation to figure out what A and C are. Well, so in our case, we're going to be using the 30-degree angle because that's the only one we know, even though technically we know the other one as well. So what we're going to be saying is sine of alpha, which is sine of 30 degrees, in our case, this should be equal to the opposite side over the hypotenuse. Well, so if this is opposite, if this is our angle 30 degrees, then that means the 7, so our opposite side is equal to 7. That tells us our adjacent side, well, it's the letter A. We don't know what it is. And our hypotenuse is unknown to us as well, and that's equal to C. So, but we know that sine of any angle is opposite over hypotenuse. So what we have is opposite, which is 7. We have sine of 30 is 7 over our hypotenuse. So we don't know what our hypotenuse is, so we'll call it C. So what this does for us is it sets up the equation sine of 30 degrees is equal to 7 over C. And so you can either use your calculator to figure out sine of 30 degrees. And I'll rewrite it here on the new page. And for the homework, it's totally fine to use calculators. Do the problems however you want. On the exams, you won't necessarily need a calculator, which is why it wasn't part of the required materials. But we also know what sine of 30 degrees is from the work that we did before. So if we just scroll up a little bit, you'll notice we have sine of 30 degrees right here equal to 1/2. So I already know what sine of 30 degrees is. And what I really want to figure out is what C is. So I don't want C on the bottom, right? So I can multiply both sides by C. And so I have C times sine of 30 degrees is equal to 7 because the c's cancel out. And then I know that sine of 30 degrees from before is 1/2 from the work that we did, or you can just plug it into your calculator, sine of 30 degrees, and you'll get 1/2 as well, or 0.5. So we have c times 1/2 is equal to 7. And now to get rid of that 1/2, what I'm going to do is multiply by the reciprocal, 2/1. So if I multiply the left side by 2/1, I have to multiply the right side by 2/1. So the 2's cancel. And so we end up with c is equal to 7/1 times 2/1, which is 14/1, which simplifies to 14. So that tells us that this side of the triangle, our hypotenuse, is equal to 14. And so now, if we want to figure out what a is, well, we need to use something that is in reference to alpha. And remember that a is our adjacent side, so we want to use one of these that has an adjacent in it. So using sine again won't help us because sine only uses the opposite and the hypotenuse. So that what we could do is use cosine because it has adjacent, or we could use tangent. I'm going to stick with cosine, but you can do the problem however you'd like. This is one of those cases where, like in a lot of math, you can kind of choose your own adventure. So what happens here is we have cosine of alpha, and here alpha is 30, so it's cosine of 30 degrees is equal to, and remember cosine is adjacent over hypotenuse, and our adjacent side here is just the letter a, but our hypotenuse, now we know it, so we can write 14 rather than just writing c. So here we had c, but we know it's 14 now, so we don't have to use c anymore. And so we have cosine of 30 degrees is equal to, so adjacent is a, but hypotenuse we know is 14 now. We no longer have to use c, so we have a over 14. And here the only variable we have is a, so we want to get a by itself. So we'll multiply the right side by 14 for the 14s to cancel out. If we do it to the right side, we have to do it to the left side. So we have 14 times cosine of 30 degrees is equal to, the 14s cancel, and we just get a. So all we have to do is a little arithmetic on the side. So you can either plug 30 degrees of cosine of 30 degrees into your calculator, or what you can do is come back up because we already did this, and we know that cosine of 30 degrees, here it is the square root of 3/2. So cosine of 30 degrees is equal to the square root of 3/2. So we can replace that. So we have 14 times the square root of 3/2 is equal to a. And so we have 14 times square root of 3/2. Well, 14 is the same as 7 times 2 times the square root of 3/2. So I've just written 14 in a different manner. And so now that you see we have a 2 on bottom and a 2 on top, and they cancel. And so we end up with 7 times the square root of 3 is equal to a. And so now we can come back up and fill in the last unknown side of our triangle. Not square root of 13, square root of 3, excuse me. Cool. And so there's that problem. All right, so I'm going to jot down some of the things that I think were important today. So what did we learn? Well, we have sine of alpha. This is opposite over hypotenuse. Cosine of alpha is equal to adjacent over hypotenuse. Tangent of alpha, that's opposite over adjacent. We have cosecant of alpha, that's just the reciprocal of sine, so hypotenuse over opposite. Write that again. Secant of alpha, that is hypotenuse over adjacent, or just the reciprocal of cosine. And cotangent of alpha, which is adjacent over hypotenuse, or just the reciprocal of cotangent. And then we found, using our proof of the 30, 60, 90 and the 45, 45, 90, that sine of 30 degrees is equal to 1/2 sine, let's see, cosine of 30 degrees is equal to root 3 over 2. Tangent of 30 degrees is equal to root 3 over 3. Sine of 60 degrees is equal to root 3 over 2. Cosine of 60 degrees is equal to 1/2. Tangent of 60 degrees is equal to root 3. Sine of 45 degrees is equal to root 2 over 2. Cosine of 45 degrees is equal to root 2 over 2. And tangent of 45 degrees is equal to 1. And what you could do as a little exercise is change all of these degrees to radians, because radians will become far more ubiquitous as we go in the course. So for instance, if we wanted to figure out what this meant in radians, or what the angle is in radians, remember, we take our degree, we multiply it by our conversion factor, which in this case would be pi over 180, because we want the degrees to cancel out, which would give us 30 over 180 times pi. Cross out the zeros so that we get 3 over 18 pi. Then 3 is 3 times 1. 18 is 3 times 6 times pi. The 3's cancel, so we just get 1 pi, 1/6 pi, or another way to write it is pi over 6, which is far more common. So you can go through that and rewrite these degrees as sine of pi over 6 is equal to 1/2. And do that for the 60 and 45 degrees if you wanted to do it a little more practice. But that will basically be it for this section. I had to break this up into 2 videos because, as you can see, my tablet's battery was low. But awesome. I'll post a section for 7.2 homework. And if you have any questions, feel free to let me know. And I'll see you guys in the next one.